Hello students, now we are going to start the topic Einstein photoelectric equation, energy quantum of radiation. Let's begin the topic, effect of frequency nu and I on the stopping potential. So variation of a stopping potential is in the form of two types. First, when the nu constant I varying and when the V varying and I constant. So let us understand one by one these both two. First, effect of frequency and intensity on a stopping potential. So we have taken I'll just taken the two particular section of a position graph where x-axis carrying the potential and y-axis carrying the photoelectric current. The potential which we have taken here, this is a stopping potential. Stopping potential. We will start the effect of frequency on a stopping potential. So let intensity be the constant at frequency and nu may be the varying stage. As the frequency increases, kinetic energy also increases. So we can say that if the kinetic energy increases, so the stopping potential also increases because of the formula K is equals to EV naught. So K is directly proportional to V. But saturation current will be same for all stopping potential. Because the number of photons are same. Number of emitted electrons will be same. Then saturation current will be same. So this is a Vs1. As we can see that stopping potential is different continuously, but the stopping current or the current actually is same. This we are knowing as the saturation current, which is not changing. Second graph which we have to make, in which stopping potential again we have taken versus photoelectric current. We will see the effect of intensity on a stopping potential. So when the frequency constant, so that time intensity of the number of photon varying. If the number of photon increases, then number of electrons emitted will be also increases. And if the number of electrons increases, photoelectric current will be increases. But kinetic energy will be maximum, so nu is a constant. Therefore, for different saturation current, stopping potential will be same. So as you can see, students, in this scenario, stopping potential will be same, but saturation current earlier which we were seeing, that is a changing. So this is the I1, I2, I3 and I4 like this. So these are the saturation current and this is stopping potential. Now let's move with some multiple choice questions. For different saturation current, stopping potential will be increasing, decreasing, same, changes. The correct answer is the same. If the number of photons or number of photoelectrons increases, the photoelectric current increases, decreases, remains constant. None of these. The correct answer for this question is increases. Photoelectric cell and its application. Firstly, we will understand the construction of photoelectric cell. It consists of a semi-cylindrical photosensitive metal plate E, which we are saying as a meter. Now, it consists of wire loop C at the collector. Both emitter and collector are supported in evacuated glass tube of quartz bulb. Construction. So it connected to an external circuit having battery of a micro emitter. Photosensitive plate E. Collector plate C. Glass tube. Now let's move on the working. So I think students you are able to see the diagram completely. Photosensitive plate, this is it, and its collector plate. One a glass tube. So when light is suitable wavelength lambda, lambda is less than lambda naught falls on the emitter. Then photoelectrons start to emit. These photoelectrons are attracted towards collector. Now the connection any electrical devices to this photocell. Due to photoelectric current, the device will be in working condition. The photoelectric cell is the device which converts light energy into electrical energy. Explore meter. So this is the exposure meter. The rate of photoelectric emission is directly proportional to the intensity of the radiation. It is the device used along with a corner of a find the correct time of explore for a good photograph. Buzzer alarm. Principle. Photoelectric effect is instantaneous process. In this application, a photoelectric cell is used to inactive relay mechanism. The light from an infrared lamp falls on a photosensitive surface of photoelectric cell. The infrared beam is invisible, and when someone crosses the beam, the light is cut off and photoelectric current is stopped. This operates the relay circuit and starts ringing the bell. Sound production from motion picture. So when the light is very powerful, the nearby object get disturbed. So for that scenario, sound tracked at the edges of the film and the falls on the photosensitive surface of photoelectric cell. The photoelectric current varies accordingly to the intensity of light transmitted by amplified sound. This varying current is amplified and fed to the loudspeaker. The loudspeaker reproduces the sound which is recorded by the soundtrack. The photoelectric cell works on the principle of which the correct answer is the photoelectric effect. In the photocell increasing the intensity of the light increases. Let's see. Stopping potential, photoelectric current, maximum kinetic energy, or none of these. The photocell is used to convert Light energy to the electrical energy. Both A and B. The correct answer is B. Characteristics of a photoelectric current and future of photoelectric current. Two electric emission occurs from the surface of a metal only when the incident ray has frequency greater than or equals to certain minimum frequency we know not, which is called as threshold frequency. The wavelength corresponding to the threshold frequency is called the threshold wavelength, which is the lambda is equals to c by nu.